Hello friends, my name is Miss Yashasvee Shastri. Today we'll be learning about the energy level diagram for molecular orbitals. The atomic orbitals are being divided and that is they form the two orbitals, that is the antibonding orbital and the bonding molecular orbital. Let's see it. Atomic orbitals form two types of molecular orbitals. The first is the bonding bonding molecular orbital, and the second one is anti-bonding molecular orbital. Right. Here the 1s here the 1s form two orbitals, that is the two molecular orbitals. The first is sigma 1s, which is the bonding molecular orbital, and the second is the sigma anti-bonding 1s. Here the sigma is bonding molecular orbital, bonding MO, and the sigma star 1s is the anti-bonding molecular orbital. In the similar way, the 2s orbital also forms the two types of molecular orbitals, that is the sigma 2s and the second is sigma anti-bonding 2s. You might call this as the sigma star 2s. Similar way, the 2p orbital forms the six types of molecular orbitals, three bonding molecular orbitals and three anti-bonding orbitals. Let us see what are those three bonding molecular orbitals. Sigma 2px, sigma 2py, sigma 2pz, and the second type, which is the anti-bonding molecular orbital of 2p, that is sigma star 2px, pi 2py, pi antibonding 2py, and the pi antibonding 2pz. Alright, so these are those six types of bonding and the antibonding molecular orbitals. We have to see the energy levels of the diatomic molecule. Okay, when the electrons are more than 14, they follow the different energy level sequence, and when the electron is less than 14 in the diatomic molecule, they form different sequence. Let us see what are those sequences. All right, suppose we see the example of the O2. O2 is a diatomic molecule and it has the 16 electron. The 8 electrons are being shared by the oxygen and the another 8 electron are being shared by the oxygen. Let us see the what is the energy sequence of the O2 molecule, which is a diatomic molecule. And before that, the first and the prior thing which we have to notice is that this is the experimentally determined data, not a theoretically determined data. That is the most important thing. So the energy level sequence follows for the diatomic molecule O2 having the 16 electron, like sigma 1s has the lowest energy, then the sigma antibonding 1s, then sigma 2s, sigma antibonding 2, sigma antibonding 2s, sigma 2pz, sigma pi 2px has this energy similar to the bonding orbital of the pi 2py, and the energy level of the sigma antibonding pi antibonding 2px has the energy similar to the pi antibonding 2py, and The sigma antibonding 2pz has the highest energy, which is the sigma antibonding 2pz. This is the particular energy sequence, and this is how the electron filling will takes place. Not only for the oxygen, but the few other examples can be the F2, which has the 18 electrons, and the Ne2, which has the 20 electrons, also follows the same order. When the diatomic molecules have the electrons less than 14, for example, in the lithium 2, that is the dilithium, that is the Be2, B2, C2, N2, dicarbon, dinitrogen, diboron, diberyllium, dilithium follows the different order in the diatomic molecule sequence, and the sequence follows sigma 1s, sigma antibonding 1s, sigma 2s, sigma antibonding 2s, pi 2px has the energy similar to the pi 2py, sigma 2pz, sigma antibonding 2px has the energy similar to the pi antibonding 2py, and the highest energy follows, that is of the sigma antibonding 2pz. The important characteristic feature which you have to see, that the energy of sigma 2pz molecular orbital is higher than that of pi 2px and pi 2py. Pi 2py molecular orbitals. So that is the main difference which you could be noting it here. So that is it for this class. Thank you.